Okay, so this is number 12. I'm gonna kind of give you a rundown as to how this chapter really works. So everything in this chapter, pretty much, every single thing is either going to be using normal CDF. Whoops, let me make that a little bit more pleasant. Normal CDF or the inverse normal command. I'm going to use the normal CDF when I'm looking for probability or a percentage. I'm going to use the inverse number when I have the probability or percentage. Whoops, percent. And I'm trying to find some specific value. Okay. Everything's going to involve this normal curve. The only thing to keep in mind besides that is if it mentions taking a sample, if it says a sample, okay, if you see the word sample or a random selection, you're taking some small group from the population, you have to remember to change your sigma. The sigma with respect to the sample is going to be equal to the sigma of the population divided by the square root of n. These are the three things you have to keep in mind for this whole chapter. Okay, so let's just run through this question. This kind of answers a good amount of stuff. So it says the population of values has a normal distribution with mu of 178.8 and sigma of 24.1. You intend to draw a random sample of size n, which is 155. So before I do anything, I'm just going to draw my normal curve just to get an idea of what I'm looking at. Okay, so I have that, and I'm going to draw my curve or something close resembling a curve, whatever, it doesn't have to be perfect. My mean's in the middle, 178.8. So it says if you take a single randomly selected value, this is not a sample. So we don't need this. We don't need that right now. It says I take a single solitary value. What's the probability that it's between 173.8, which is somewhere over here? We'll say 173.8 and 182.3. Doesn't matter where you put it. This is just to help you figure out what you're looking for. So we're saying find the probability. So I'm looking for the area between these two values. So if I'm looking for probability or percentage, I'm going to use the normal CDF. So I'm just going to go to my calculator. Second distribution. Normal CDF is option 2. And I'm going to pick my lower bound, which in this case is 173.8. My upper bound, which is 182.3. My mu is 178.8. And my sigma is 24.1. And I'm going to hit enter. Enter one more time. So the probability that my random selected thing falls between those two values is 0.1399. Okay. How else could it look? What if I said, what's the probability that the randomly selected thing is greater than, let's just say 190? So I'm looking for this area. Remember, the normal curve goes on forever in both directions. So in this case, when I go to the normal CDF, there's no upper bound. So the lower bound would be 190. The upper bound, there is no upper bound. So to show that, I'm just going to put a really, 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 really big number in, like that. Huge. So this area here would be 0.321, okay? That's just how it works. So if it's asking for greater than some value, put in a very large upper bound. If it's asking less than some value, just put in a very, very, very negative lower bound. Okay, now the second question says, find the probability that a sample of size 155. Here we have the word sample. Falls between those two values. So I'm going to go back into distributions. I'm still looking for a probability. My lower bound is 173.8 like it was before. My upper bound is 182.3 like it was before. But now, my mu is still 178.8, but now my sigma is going to be the sigma of the population divided by the square root of the sample size. So now it's going to be 24.1 divided by the square root of my sample size of 155. You can write it just like that. You don't have to figure out what the decimal is beforehand. Just sigma divided by the square root of 155. So I get 0.9598. And there's your answers. And that's it.